This tutorial is going to show you how to compute a t-test. That's a test you do to compare two means to determine if this difference, which we see, 22.25 to 24.3, is statistically significant. This is the data that we used for the lab, gathered it from the lab. Do the mean first to see if there's any difference. We have to create our hypotheses, and then I'll show you how to compute the t-test. Over here, I've written the hypotheses in symbols and in words. Take just a moment to read those. I want to show you here how to get this subscript. Click on that, come back up over here, highlight the section that you want to put in a subscript, and then you go to the Home section under Font, Subscript. The mean score for the vertical with no warm-up, that's our pre-group, will be lower than the mean vertical after they've had the 10-minute dynamic warm-up. That's our post numbers. This requires a dependent or paired t-test. Statisticians call it dependent. Excel, for some reason, calls it paired. That's okay. Let's look back at our raw data here. Effect of a dynamic warm-up on the vertical jump. We have our pre in inches and our post in inches. Go up to data, data analysis. Can't get it to come up. Give me just a moment. I sorted it out. I couldn't get it to come up because I hadn't highlighted an empty cell. Do that, hit data, data analysis, and this looks familiar. This is where you went to do the descriptive statistics. Note that you can come here and do a correlation. And for us, we're looking at the t-test paired to sample. Now this should start to look familiar. You go back and grab the pre-scores. In the second variable range, you grab the post scores. Hypothesized mean differences. We hypothesize, this is your null hypothesis. There is no difference, so you put 0. Even though we hypothesize there will be one, this is the null hypothesis. This is our alternative hypothesis. Labels, alpha, just leave it at what it comes out at. Select the output somewhere next to our hypothesis. Right here is where I have it. I don't want it to overwrite existing data. Let me pick a different cell here. I'm going to put it maybe right here. There we go. This is what will come out. T-test paired to sample for means. Reminder that you can come up here and click between N and O. Double click it and it moves that out so I can read all of those values. I'm going to tell you now how to interpret this printout. Let's highlight the values that are important to us. It redoes the mean for us. I'd like to come back and look at the means we generated. This is a good way to get a double check to just ensure that you didn't accidentally include some wrong data. If those are matched up, that's helpful to know. A couple other figures we want to look at. Degrees of freedom. Degrees of freedom is n minus 1. N, if you remember, is our sample size. That's why I had you highlight the count. The count is the sample size, which is n. N minus 1 is 33. The next thing I want to look at is the t-stat. I'm going to highlight those with different colors, and you'll see why in just a moment. T critical. For this example, we use one tail. I'll come back later and explain why that is. What we're looking for here is to determine if our t-stat is greater than the t-critical. That indicates then that statistically, the difference we see here in the means is significant. T-stat minus 10.39, you can report that as negative 10.4. And then is that greater than this t-critical value, 1.7? It is. That means that our data is statistically significant, these means. Where do these values come from? The t-critical is generated based on your sample size. Anyone that does research and has 34 subjects, this is going to be the same t-critical. You have to meet that threshold in order to show that your data is statistically significant and you didn't make an error. The t-stat is unique to us and based on the values we use to generate the mean. The last thing we look for, and p, small lowercase p, less than 0.05. Let's go up here and look at this. We're going to use the one tail again. I'm going to use a different color. Here's something to note. Whenever you get this E, that means e to the negative 12. Look up here. Negative 12 means that I move this decimal point from here over 12 spaces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 3. That's our value. 3e to the 12. Is p less than 0.05? Yes. We come back up here and look at our hypothesis. The average vertical jump scores will increase after a 10-minute dynamic warm-up. We can write, we accept our hypothesis. There's a more formal way to write that up, which I'll show you later on in class.